It's just a quick video this evening to show you what I've been up to. This is a meter I bought off eBay. It's lovely. It's a huge, great amp meter. I thought it would look quite nice in the workshop if I can mount it in a box. The only problem is it requires an external current shunt or a current transformer. Now the current transformer it requires is a 15:1 ratio. You put 1.5 amps into here and it will show 15 amps full scale deflection. So a normal resistor in series won't be effective because you'll get too much of a voltage drop. You won't get an accurate reading either. Now these are some current shunts here that I've got out of a scrap piece of equipment at work, a 400 cycle rotary converter, and I saved these current transformers because I thought they might have been useful, but unfortunately these are 20:1 ratio, so therefore even though the ratio is slightly higher, it doesn't, because this meter has quite a heavy burden current on it. Its internal resistance is about 12-13 ohms. I can't, with one transformer, I can't get enough deflection on the meter. So I was trying to work out if I could somehow make it work with two transformers in series or parallel. I want to come up with, and I'm not entirely sure why it works, is what I've done is these are the primaries of the transformers here. This is the primary here, and that's the primary of the other transformer. I've wired those two primaries in series so that basically the current's going through this transformer. This is my supply, an AC transformer here out of an old amplifier. So I'm basically shorting out the transformer and feeding it back again. So that's my current supply, and the fluke is measuring the primary current. And what I've done for the secondary is I've wired the two secondaries in parallel. If I wired them in series, it gave me a lower reading. When I wired them in parallel, obviously I've got more current capability to overcome the burden of this. So therefore the extra current has given me the output I want. I did also try wiring the primaries in parallel, and that gave me no extra benefit at all. So the primaries are wired in series and the secondaries are wired in parallel. Initially when I tried it, I got much more deflection than I needed, which was the first time. I was always getting well under deflection. So if I was putting in, say, 10 amps, I was getting sort of about 6.5, 7, and there was no way to get enough indication on the meter, i.e. the meter was under reading all the time. But with this modification, then I was getting over reading, which is a lot easier to cope with because I can shunt that down with resistors and things. So what I've done is I put these three power resistors you see here, 10 ohms. So we've got 3.3 ohms in parallel with this meter. And let me show you what I've come up with, and this is going to be the plan for the workshop meter. Only because it looks nice more than anything. I mean, it's not really necessary. I've got lots of ways of measuring current, but it's quite a nice way of a quick visual check to see how it works. So I'm using the variactor winding power into the primary of this mains transformer, and basically we're shorted across the output of the secondary, so all the current going to the secondary is being indicated by the fluke here. So let's go to 3 amps. And as you see there, that's the first deflection there, 3 amps. Let's increase it. Let's increase it to, let's go to 6 amps. About 6 amps. 6 amps. Let's take it to 13 amps, which is the maximum for the UK mains. Now bear in mind this is a lower voltage from the secondary of the transformer, so I'm not drawing so much current from the mains as I'm indicating here. There's my 13 amps. Don't want to keep it too long because it's overloading transformer. But there you go, just over 13 amps. So it looks like it's going to be quite a nice sort of and a fairly accurate way of measuring input currents for sort of anything really, any power being used in the workshop. I plan to mount it. If I can find some wall space, mount it on the wall with the current shunts incorporated, and hopefully that would make quite a nice instrumentation readout for the workshop. Anyway, thought it might have been interesting. It was just a bit of a mess around evening, really. And thanks for watching.